What are we seeing?
Smoke ring.
A ring. Yes, so this shape is a type of vortex we call a toroid. You'll see that ring shape. Try not to hit the smoke alarms. But that ring shape is like if you took the two ends of a tornado and hooked them together. It's turning in on itself constantly. And we have to empty all the rings out. Don't worry, family. It is just water vapor, really, a little bit of stabilizer so that it doesn't set off our smoke detectors that easily. All right. Now, we've been showing some cool stuff, but now I want to show you guys the coldest thing we have at the Museum of Discovery. Does anyone want to take a guess of what might be the coldest thing we have? Liquid nitrogen. That is exactly it. Dry ice is a really good guess, but it is a little warmer than our liquid nitrogen is. So, liquid nitrogen is negative 321 degrees Fahrenheit. Now, I want you guys to repeat after me. Say negative 321 degrees Fahrenheit. There you go. Now you know the temperature of liquid nitrogen. So that is its boiling point. When we talk about solids, liquids, and gases, when a liquid turns into a gas, it's at its boiling point. Now, normally, we're used to like water having a boiling point of 212 degrees Fahrenheit in the positives. Liquid nitrogen thinks everything is boiling all the time. So I want you guys to watch what happens when we put a little bit in our beaker here.
I know this water. I actually do. It's very cold water.
Yeah. Now, that is just straight nitrogen. So that big breath we took earlier with our oxygen, we actually weren't breathing in that much oxygen. 78% of the air we breathe is made of nitrogen, this stuff. We just get this from a lab that cools it down and makes it awesome. But yeah, you'll notice it's boiling, because it is super cold. But the air around us, 70 degrees, really hot. My hand, roughly 80 to 90 degrees, also really hot. So I can do that once, I can't do it a lot. But, all right. Now, with our liquid nitrogen, my favorite thing to do is to get out some super scientific materials. So we've got this. Does anyone know what this might be? A rubber band, right? Well, we've got some super scientific rubber bands today. And what's fun is we can pop it in the liquid nitrogen. Yeah. So normally, rubber bands are, what would you say I'm doing right now? Stretching it. Rubber bands are really stretchy. It's because they're made up of molecules called polymers. They're like these big chains. Imagine this molecule, but repeated over and over. So that makes them super stretchy. But when we get cold with our rubber bands, just like how when you get cold, you might huddle together really small, trying to get warm, that's what all the molecules in this rubber band are doing. They're getting really close together, shrinking down. And that changes the way the rubber band works just a little bit. A little more brittle. So we'll do that again real quick. Sorry, rubber band. Indeed. It breaks real easily. Now, when you get it warmed back up a little bit, it's stretchy again, which is super fun. It may be a little more brittle than before. It might break a little easier, but it's stretchy. Now, we've got some other types of polymers. We've got these balloons. Now, what's really cool about these polymers is it's still that really stretchy material, but now it's filled with air. So when we put this in liquid nitrogen, we should expect I'm sure that won't happen again. You know what's really crazy is science is all about repetition. So you have to be able to repeat an experiment to do it correctly. So we'll blow up another balloon, see if we can get this polymer going. Now, our liquid nitrogen, you see it's got a lot of fog coming off of it. We're going to utilize that in just a minute. Maybe I should just go with the ones I made earlier. I think that might be a little safer for everyone. Everyone say hi to my friends Rachel and TJ.
Oh,
hi, Rachel and TJ.
Very good. Now, these little guys, same thing. They're filled with what?
Air.
Air, exactly. So, do you guys think that they could go into our liquid nitrogen? They really love to swim.
What are the balloons called?
You think they do that? Do you think I can fit both of them in there?
No. Only
No?
one. Not different.
Swimming temperature's a little off. Well, luckily these guys are trained Olympians, so we're just gonna have them. Bloop. There goes Rachel.
She done killed the balloon.
Goodbye, Rachel, indeed. Down she goes. You guys think TJ can fit in there too?
Yeah.
Let's go. All right, TJ.
Oh my God.
She killed my friend.
TJ is just fine in there. Now while they're going for a little swim, what do you guys think would happen if I took them back out?
The pops.
Oh, pop? Well, let's find out. So we'll shake TJ off here. He's had a nice little swim. Same thing with Rachel.
They're pop?
Oop, get out of there, Rachel.
They're coming back.
They're coming back.
I get it.
So, you know how all those molecules are shrinking down and get really close together when they get cold. So now that they're getting warm again, the air is stretching back out. It's going, oh, thank goodness, that was not appropriate swimming temperature. I need to stretch back out. And now we've got some little friends. They're maybe a little more messed up than they were, but they're all right. Now, if we have something made of plastic or a polymer that doesn't shrink down, but it's still filled with air, what's going to happen? So these guys, these are playpen balls. And so they have a very hard external shell. You can't really squish them in much. They're really hard to squish. What do you guys think is going to happen? So we're going to do something where we form. Yeah, we're going to do something called forming a hypothesis. Everyone say hypothesis.
Hypothesis.
Hypothesis is a type of guess that scientists use, but they try to make a hypothesis based on what they know. So when I asked you what do you think is going to happen, your answer, based on what we just saw, is a hypothesis. So everyone turn to your neighbor while we plop these into the liquid nitrogen and tell them what you think is going to happen.
I think they're gonna pop and then they're gonna come back alive whenever
I think it might change colors.
I think it might change to pink.
Or turn into a unicorn. Those are my two hypotheses. They're not very well supported. But.
No.
She
All right,
said, I
everyone
think
got your
it's gonna turn
hypothesis
into a
ready?
unicorn.
All right, we are going to pull this out now. If you don't like loud noises, this is a little bit of a warning. You might want to cover your ears for this part. You ready? 3, 2, 1.
Oh, that's not loud.
It is kind of like an egg hatching, right? So, what just happened?
It popped.
It broke and it looked like it exploded. So I'm going to explain it now while we have our second one down here.
That was.
So as that air was shrinking down on the inside of the ball, the plastic couldn't move around it. So we were actually forming a space where there was no air at all. That's called a vacuum. So whenever we hit the ball and break it open, all the air that wants to be in the ball comes rushing back in and makes a cool implosion. Noise warning. That was a really good one. Those are super fun. We always wear our safety glasses here at the museum to be safe. But that is pretty cool. Now, I don't know about you guys, but it's around my snack time today, and they say no food or drink in the museum, so please don't tell them I'm doing this, but I'm just gonna drop my snacks in here if you don't mind. Do you guys like Cheetos?
Yeah.
Cheetos are pretty good. They're also really fun if you have some liquid nitrogen on them, so.
Oh yeah.
That's pretty good. Do I have any brave adult volunteers who would like to have a little snack?
Go, Mama.
We need to be over 18. You look very excited back there. Let's get in. Come on up.
Where don't you want to go?
Well, I may only have one pair of safety glasses, which is a problem. We can do this one at a time. We'll need to have the safety glasses move with whoever has the Cheeto. We'll have you go first over here. What's your name? Laylee? That's a wonderful name. What's your name, sir? Hayden. Hayden and Laylee. Have you guys ever eaten a liquid nitrogen Cheeto before? Okay. So, do you guys know like those old movies where the kid licks like a telephone pole in the ice and their tongue gets stuck? Yeah. So we don't want that to happen to you. So this is where I need your guys' help, is we're gonna yell as loud as we can at our adults up here while they're having this Cheeto to remember to chew, all right? Can we give it a quick practice real quick? Say chew, 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 chew. Wonderful. Okay, Lily, you are up first. And you're gonna give it a little twirl in your hand just to get some of that. And that's boop. Wonderful job. Give them a round of applause. You did great. All right. Are you ready now, guys? We gotta remember. I don't know if Aiden's gonna remember what we need to do, so we gotta be loud. Set that down for you. Pick it up. Give it a few spins.
Twirl
with
your fingers.
and then pop it in. Wonderful job. There you go. Everyone give them a round of applause.
Did it taste
You're very
different?
brave today.
No? Just cold.
Now, guys, I have some sad news. It is getting towards the end of our show.
to do fruit
I know. It's really sad. However, I have one last big experiment.
Right.
So, you know how earlier we were talking about how cold liquid nitrogen is and how hot water is when you boil it?
Oh.
Yeah, so, does anyone remember how hot boiling water gets?
212 degrees Fahrenheit.
212 degrees Fahrenheit. Good job. That's exactly, or 100 Celsius. But we use Fahrenheit here because we unfortunately don't know enough of the metric system. The United States has our own stuff, and that's fun sometimes. But yes, 212 degrees is what boiling water is at. Now, whenever we combine a liquid that is negative 321 degrees Fahrenheit with a liquid that is positive 212 degrees Fahrenheit, things can get a little crazy. So I want you guys, again, turn to your neighbor and tell them what you think is gonna happen. Give them your hypothesis.
Ice.
It's gonna
You're
Fly
burning
over.
hot and cold. It's gonna freeze.
freeze, yeah.
All right, everyone got their guesses? Good deal. Okay, now, friends, I need from you one final countdown. Can everyone go 5?
5, 4, 3, 2, 1. Finish it! Oh, that's what I said at first. You said no.
I didn't know. Look up top.
Now we have some rain from the ceiling. I'm gonna bring this around. You guys can get out of your seats at this point and you can feel
I'm not
where
doing that.
you just went to down here. Yeah, you can feel how cold that